Hi guys, and welcome to the third of our six-part video sequence going over all of the commands and information necessary for programming 1. In this Unit 3 video, we're going to be going over functions, as well as going over a little bit of review from Unit 2, talking about variables and inputs. Now as we go through and create our program here, first thing we're going to do is we're going to touch in a little bit on our Unit 2 programs. When we look at programming in Unit 2, we were talking mostly about variables and inputs. When we look at Unit 2, we are primarily talking about variable types as well as inputs. So we're going to briefly demonstrate a couple of our variable types, as well as the differences between those guys and how to utilize them in inputs. Now, the first variable type that I want to go ahead and bring into notion here is going to be the string variable type. So we give this variable a name, such as name, and then assign the type, string for it. This variable type is going to be used to store text information into the compiler. Now I'm going to assign an input to this guy here, saying name string equals an input, and then giving the user a prompt, what is your name? Put my wait key end, and now my program should end up simply asking for what is the user's name. Okay. One of the other things that we're going to include in this is going to be another input where we're going to ask simply cost. Now cost is going to end up including dollars and cents, and as a byproduct then we're going to want to use the float variable type, which is going to differ from the regular integer variable type. Integer variable type is not going to keep track of any sort of decimals, and so we definitely want to, as we're going to have dollars and cents, have cost located in here. Okay, so with cost I can ask an input, what is the cost of the item? Simple enough. I'm going to get rid of this line of code here real quickly, and we're going to start off by including just simply what is your name, and then I'm going to ask for the amount of soda that you are looking to purchase. So soda equals an input. How many sodas would you like to buy? Okay. Now, I can simply run this program right here, and a lot of your Unit 3 programs would be simple enough to where you can run them without functions. However, the important part about Unit 3 is that we are learning functions on a very simple basis so that when we get to more complex functions, we understand how they work. Now, a function is very useful for several reasons. Number one, it allows for us to organize our thought into chunks of code. Number two, it also allows for us to repeat this as needed throughout the program. So, to start off by declaring a function, we simply start off with function as our command. I'm going to create a little bit more room here between my graphics menu. So I'm going to say function as my command, and then I need to give this a actual name associated with this function. Since I'm asking for information, I'm going to call this getInfo. Okay. Now you can call your function anything that you want to call it, as long as it is not the name of a command already in Blitz. Okay. Now this next part is also very important here. You always want to, when you're starting a chunk of code, such as a function, tab that over. The reason being that if I was to try and run this program right now, I'm going to get an error. That error tells me expecting end of function. When I tab my code over, I can clearly see that I have started a block of code, but I have not finished that block of code. And Blitz will not run properly if we do not have this block of code ended. So, in order to make it painfully obvious on ourselves and anybody that we are looking to help us debug our code, we want to always have our code nice and clean and tabulated over properly so that I can see quite obviously that this has not been ended. Now I'm going to end this function with quite simply end function. Now if I was to run this, you'll see that I get my blank window, and normally I would be expecting to have my inputs. However, when we're talking about functions, just because we have created that code does not mean that we are actually using it. This is actually quite a useful thing when it comes to functions, because I can stick this code after my end statement, and my program as a whole can simply be this bit of code up here. Now, in order to use this code that I have just created, I need to call the function. So I'm going to type in here getInfo. Blitz is very helpful in that it is not case sensitive. However, as we are looking to have our skills be translatable to other languages, which are case sensitive, it's good for you guys to get into the habit of keeping track of case sensitive stuff, such as this capital I for the getInfo function. Okay. Now that I call this getInfo function, Blitz, when it gets to getInfo here, is going to come down and immediately run the bit of code that I have in my function. So I can now ask, what is your name? And how many sodas would you like to buy? Okay, pretty simple enough here, but this really isn't that useful as a program, so we want to add some more usefulness to this program. The nice thing with functions is that I can create a bit of code and call it at any certain point, whereas my functions can all be kept after my program has ended. So this function will be simply called calc, where I will be calculating the cost of buying a set amount of sodas. In order to do so, I'll have my cost variable that I had talked about earlier. I'm going to have that equal to soda times, and let's make this 99 cents. So soda times 99 cents, just like with my other function, I need to make sure I end this function. So I've created a new function, assigned some sort of code associated with it, and now I've ended this function. In order to actually call this, after I've gotten the info, I need to call the function calc. And then finally, I need to print out my information. So let's create a third function. We'll call this print_info. Now it's important to note that I cannot simply call this print because print is a command stored within Blitz. And so I need to give this some additional name information as well. So since we are printing out information, we'll call this print_info. From this command, I'm going to print, and I'm going to put name string in here, and then I'm going to conjugate, which is what we call this plus sign here with this. So just like when we conjugate verbs in Spanish, this conjugation in programming allows for us to add additional stuff to our base, which would be name string here. So we're printing name string plus, and we're going to put an apostrophe s, total beverage cost is, and then I'm going to put a $sign on this, and conjugate once again with cost float. Now when I run this guy, actually let's put the end function on here. When I run this program here, and call for print info, I'm going to fill out my information. I'm going to buy 3 sodas. It should cost me $2.97. However, you'll see I get a blank total beverage cost is $0. This is because when we are dealing with functions, functions do not share variables. We need to tell them that we want to share our variable universally throughout our program. We do so using a global statement. This global statement should come up in here after we've declared our graphics. We're going to say global, and then we're going to declare our variables that we want to share throughout the program, such as name string. Now I can separate these variables with a comma and give another variable in here, such as soda. Or I can create another global statement if I get 12 or 13 variables that start taking up too much space on my screen. I can create another global statement and simply bring those guys down below to where I can share, for instance, cost float. Now as I run this, and I buy my 3 sodas, and I get my $2.97, my program is now very useful again. One of the reasons why we would want to use functions for this, as opposed to just simply coding this, is if I come over here, and let's say that the cost of soda has changed, I can simply click on the calc button right here, and it would bring me immediately to this calc function. So if I put this down here, to where it's completely off the screen, my program decided that it needs to change the cost for the calculation on there. Click on calc over here, and it quickly brings up the cost then for soda. So now soda can now become $1.29. And my program remains unchanged, whereas I'm simply just changing a small amount of the code within a function. Okay, so very, very useful. Moving this function around has absolutely zero impact on what actually happens within the code here. Changing that 129 doesn't change what any of these other functions have going on, as well as it doesn't change anything within the actual program aside from the calculated cost, which is what we were hoping for. Okay. Now, a couple of things to note. Number one, at this point you may be thinking, well, I'm just going to globalize all of my variables. And that would be actually very sloppy of you to do. Just like when we were talking about why we wouldn't want to utilize a float in every instance versus an integer, there are reasons why we don't want to globalize all of our variables unless they are absolutely needed to be globalized. First, globalizing takes up a little bit more space. So you guys probably aren't going to run into any sort of issues, but as we start getting into larger and more complex codes, globalizing everything is going to cause for more memory space on your guys' programs, which is not necessarily needed. Second, when we declare these variables up here, we are essentially declaring them for the first time and creating them. So if I'm creating all these guys before I actually get into my program here, I'm increasing my load time. If I'm doing so on variables that don't need to be globalized, then I'm increasing it unnecessarily. So keep track of the variables that you're going to be sharing or need to share and globalize those ones. Don't globalize ones that you don't need. Okay? So that's a very important thing. Now, let's say that for some reason Pepsi is giving away soda, or they're going to be giving out this random sweepstakes where you go to purchase a soda and your cost can vary anywhere from free to $2 for your soda that you're looking to purchase. We need to create some sort of random number in here then. We're going to do so using the rand command. So rand is going to allow us to assign numbers that we want to go between, also including those two endpoints. So when I say rand right in here, I'm going to generate a random number between 0 and 2. Running this program, Josh is going to buy 2 sodas. You see that clearly my soda cost was $1. If I was to run this again, buying 2 sodas, I get $2. And if I was to continue doing this over and over and over again, you'd see that I am perpetually ending up with $1 for the cost of each of my individual sodas. Now, that may seem like I'm not getting any sort of random number and that random command is quite useless, when in fact, the random command is actually doing exactly as it's supposed to do. When we're talking about a random command in programming, that random command is based upon an algorithm or a mathematical sequence. Okay? And there's a lot of money in developing a better random number generator, but we can't simply just expect to go and pick a number from a hat like we would in the real world. So since I'm dealing with a mathematical sequence, if I was to set that mathematical sequence to simply +2, so we got a very simple mathematical sequence, and I'm always starting with 2. So I've got a start point of 2 and a sequence of +2, and I'm adding 2 plus 2, my math is going to give me 4 for my number. It doesn't matter how many times I ask you 2 plus 2, I'm always going to get 4 for my mathematical answer. And just like that, the rand statement works where we are always starting from the same start point, so we're always getting the same end value. The only way that we can switch this is if we were to create a different start point. And the way we're going to do that is using the seed rand command. So seed rand is going to establish a new seed for any of our random statements. We're going to set this to be the millisecond value of the clock internally on each of the computers. So the only way that we could get the same mathematical sequence would be to have the millisecond value of each of our times running this program be exactly the same, which is highly unlikely. So now that I run this, I can still get $1 for my cost here, but I'm going to have variability between my answers now. So you'll see at this point, my soda purchase was free. If I was to run this one more time, my cost was $1 per soda. Now, it's very unlikely that we would be getting free soda from Pepsi, nor would we also be probably paying for an exact dollar amount. So Pepsi, in their knowledge, is probably going to be charging us somewhere between 50 cents and $1.50. We can get that floating value by getting rid of the A on our rand statement down here. So if I go from RAND to RND, that introduces floating points. Likewise, I can change my start points to now be between 0.50 and 1.50. Now when I calculate my values right in here, and buying 2 sodas, you'll see that I got approximately somewhere in the neighborhood of $1.32 for my cost per soda. So I now have variability on a much greater scale, and we can probably ignore the rest of this stuff here and round this off. We can go through a little bit of math to try and simplify this down to 2 decimal points. However, for your guys' programming sake, we don't need to do that for right now. Okay? That's going to be the rand or RND command. So RAND, RND, very different in what they produce, both very useful. Okay? Finally, you'll notice that when I start up Blitz right here, I've got Blitz with a little header across the top, and when I run my programs, I have absolutely nothing up here. So the last command that we're going to be going over in Unit 3 is going to be called the app title command, and it's quite an easy one to remember, as the app title is simply created by calling app title. Now your guys' app titles can be anything that you want. You don't have to simply put JKU3P1 for these, okay? You can put whatever you want. So since we're dealing with soda math right in here, let's call this one our funky soda math. Okay, this is going to calculate our soda math in here. It gives us a little bit of a title as far as what this is going on, and it's got some sort of creative process associated with it. Whatever you guys choose to use for your app title, you can feel free to choose whatever you want, as long as it is school appropriate and pertains to something, obviously, with your program. Now, I don't care if you want to tell me a joke on it, have some fun with your guys there. That's all recommended right there. Okay, so have fun with your app titles, and like I said, just keep them school appropriate. Okay, so in summation here, we've got functions, and the important thing that we have with functions is that we create them and call them when needed. If we are using variables within those functions, it's important that we globalize those variables, okay? And if we are using any sort of random number, in order to truly get a random number, we need to make sure that we set the seed ran to be something that is going to have variability in it, such as the millisecond value of the clock. Finally, include app titles on all of your guys' Unit 3 programs and any programs here going forward, so that we can clearly see some sort of information about the program. That'll do it for all of the Unit 3 commands. Feel free to stop, pause, rewind this video, and rewatch it as many times needed. And good luck with your programming in Unit 3.